Hello students, welcome to our live APS classes, and as all we know that this is our foundation course, especially for the students from 9 to 12. And in our today's live lecture, we will discuss or continue with our new chapter, that is chapter number 3 for class 12. And the name of the chapter is Electrochemistry. And today we will discuss important 25 MCQ questions or objective questions regarding this chapter. So first of all, welcome to all the students who joined with us our live APS classes. And now let us start with our important objective questions or MCQ questions regarding this chapter. So welcome back to our live APS classes again. So due to some network problem, there is technical fault. So once again, good evening to all the students who joined with us our live APS classes. And now let us start with our new chapter, that is chapter number 3, and the name of the chapter is Electrochemistry. And regarding this chapter, important 25 MCQ questions or objective questions that are to be discussed in our today's live lecture. So let us start with our first question, and our first question is if 96,500 coulomb electricity is passed through copper sulfate solution, it will liberate. I repeat again, if 96,500 coulomb electricity is passed through copper sulfate solution, it will liberate. Options are 63.5 gram of copper. Second is 31.76 gram of copper. Third one is 96,500 gram of copper. And the last one is 100 gram of copper. That means if 96,500 coulomb electricity is passed through copper sulfate solution, it will liberate. Options are 63.5 gram of copper, 31.76 gram of copper, 96,500 gram of copper, and the last is 100 gram of the copper. So now, out of these four options, which is the right option? So if 96,500 coulomb electricity is passed through copper sulfate solution, it will liberate 31.76 gram of copper. Not 63.5 gram of copper, not 96,500 gram of copper, and not even 100 gram of copper. Only 31.76 gram of copper is liberated if 96,500 coulomb electricity is passed through copper sulfate solution. So here option B is the right answer for the question number 1. Next is your question number 2, and your question number 2 is fused NaCl on electrolysis gives dash on cathode. Fused sodium chloride on electrolysis gives on cathode. Options are chlorine, B sodium, C sodium amalgam, and D is hydrogen. Fused sodium chloride on electrolysis gives dash on cathode, either chlorine, sodium amalgam, and the hydrogen. So fused NaCl, if the fused NaCl on electrolysis gives sodium on cathode. Gives sodium on cathode, not chlorine, not sodium amalgam, and even not hydrogen. But only fused NaCl on electrolysis gives sodium on cathode. So here option B is the right answer for the question number 2. Next is your question number 3, and your question number 3 is the standard electrode potential for the half cell reactions are Zn give rise to Zn2 positive plus 2 electrons, E naught is equal to 0.76 volt. Second one is Fe give rise to Fe2 positive plus 2, E naught give rise to minus 0.41 volt. The EMF of the cell reaction, that is Fe2 positive plus Zn give rise to Zn2 positive plus Fe, is either minus 0.35 volt plus 0.35 volt, minus 1.17 volt, and plus 1.17 volt. The EMF of the cell reaction is Fe2 positive plus Zn give rise to Zn2 positive plus Fe, is either minus 0.35 volt plus 0.35 volt, minus 1.17 volt, and plus 1.17 volt. And it is the question number 3. So the EMF of the cell reaction, that is Fe2 positive plus Zn give rise to Zn2 positive plus Fe, is plus 0.35 volt. Plus 0.35 volt. So here option B is the right answer for the question number 3. That is plus 0.35 volt. So here option B is the right answer. Next is your question number 4. Which of the following is the secondary cell? Options are Leclanche cell, lead storage battery, concentration cell, and D is all of these. Which of the following is a secondary cell? Options are Leclanche cell, lead storage battery, concentration cell, and all of these. So out of these, you have to find out which is a secondary cell, and it is your question number 4. So Leclanche cell is not a secondary cell, concentration cell is not a secondary, storage battery, lead storage battery, lead storage battery is a secondary cell. That is, lead storage battery is a secondary cell. So here option B is the right answer. Next is your question number 5, and your question number 5 is for a certain redox reaction E naught is positive. This means that delta G naught is positive, K is greater than 1. Second one is delta G naught is positive, K is less than 1. C, delta G naught is negative, K is greater than 1. And the last one is delta G naught is negative and K is less than 1. That is for a certain redox reaction, E naught is positive. This means that either delta G is positive and K is greater than 1. Delta G is positive, K is less than 1. Third is delta G naught is negative, whereas K is greater than 1. And delta G naught is negative and K is less than 1. So for a certain redox reaction, E positive, E naught is positive. That means, it means that delta G naught is negative and K is greater than 1. Delta G naught is negative and K is greater than 1. Greater than 1. So that means for a certain redox reaction, E naught is positive. This means that delta G naught is negative and K is greater than 1. इसका मतलब ये हुआ कि delta G naught is always negative and K is greater than 1. So here option C is the right answer for the question number 5. Next is your question number 6, and your question number 6 is cell reaction is spontaneous when option A is E naught is negative, B delta G naught is negative, C E naught oxidation is positive, and D is D is delta G naught is positive. That means cell reaction is spontaneous. When E naught reduction is negative, delta G naught is negative, E naught oxidation is positive, and delta G naught is positive for a certain cell reaction. If cell reaction is spontaneous, when either E naught reduction is negative, delta G naught is negative, E naught oxidation is positive, and delta G naught is positive. That means there are 4 options for the question number 6. So for a cell reaction that is spontaneous, so cell reaction is spontaneous when delta G naught is negative. Delta G naught is negative. Not E naught reduction is negative, not E naught oxidation is positive, not delta G naught is positive. But for a cell reaction that is spontaneous when delta G naught is negative. So here option B is the right answer for the question number 6. That is delta G naught is negative. Then for a cell reaction, if it is spontaneous, then delta G naught is negative. Next is the question number 7, and your question number 7 is equilibrium constant, that is K, is related to E naught cell and not E cell. So equilibrium constant, that is K, it is related to E naught cell and not E cell because option A is E naught cell is easier to measure than E cell. Second is E cell becomes 0 at equilibrium point, but E naught cell remains constant under all the conditions. Third one is at a given temperature, E cell changes, hence value of K cannot be measured. D, any of the terms E cell or E naught cell can be used. Any of the terms E cell or E naught cell can be used. That means for equilibrium constant, K is related to E naught cell and not E cell. Because there are 4 options, so you have to choose the right option for the question number 7. E cell becomes 0 at equilibrium point. E cell becomes 0 at equilibrium point, but E naught cell remains constant under all the conditions. That is, E cell becomes 0 at equilibrium point, but E naught cell remains constant under all the conditions. So here option B is the right answer for the question number 7. That is, equilibrium constant K is related to E naught cell and not E cell because E cell becomes 0 at equilibrium point, but E naught cell remains constant under all the conditions. Next is your question number 8, and your question number 8 is molar conductivity of 0.15 mole solution of KCl at 298 Kelvin. If its conductivity of 0.0152 second centimeter inverse will be option A is 124 ohm minus 1 centimeter square mole inverse, 204 ohm 1 centimeter square mole inverse, 101 ohm 1 centimeter square mole inverse, and 300 ohm 1 centimeter square mole inverse. So if the molar conductivity of 0.15 mole solution of KCl at 298 Kelvin, but conductivity of 0.0152 second centimeter inverse, it will be 101 ohm 1 centimeter square mole inverse. That is option C is the right answer for the question number 8. So the molar conductivity of 0.15 solution of KCl at 298 Kelvin, if its conductivity of 0.0152 second centimeter inverse, it will be 101 ohm 1 centimeter square mole inverse. So here option C is the right answer. Next is your question number 9, and here question number 9 is electrical conductance through metals is called metallic or electronic conductance and is due to the movement of electrons. The electronic conductance depends on. Electrical conductance through metals is called metallic or electronic conductance and is due to the movement of electrons. The electronic conductance depends upon option A is the nature and structure of the metal, B the number of valence electrons per atom, C change in temperature, and D is all of these. Electrical conductance through metals is called as metallic or electronic conductance and it is due to the movement of electrons. The electronic conductance depends upon either the nature and the structure of the metal, the number of valence electrons per atom, change in temperature, and D is all of these. So here electrical conductance through metals is called as metallic or electronic conductance and it is due to the movement of electrons. So here the electronic conductance depends upon the nature of the metals and the structure of the metals, the nature of the valence electrons per atom, and the change in temperature. That means all these factors are responsible for the electronic conductance. Or in other words, we can say that the electronic conductance depends upon the nature of the nature and the structure of the metal, the number of the valence electrons per atom, and the change in temperature. That means all these factors are responsible for the electronic conductance. So here option D is the right answer for the question number 9. That is all of these. Option D is the right answer. Next is the question number 10, and the question number 10 is the specific conductivity of N by 10 KCl solution at 20 degrees Celsius is 0.0212 ohm inverse centimeter inverse, and the resistance of the cell containing this solution at 20 degrees Celsius is 55 ohm. The cell constant is the specific conductivity of N by 10 KCl solution at 20 degrees Celsius is 0.0212 ohm inverse centimeter inverse, and the resistance of the cell containing this solution at 20 degrees Celsius is 55 ohms. The cell constant is option A is 3.324 centimeter inverse, B 1.166 centimeter inverse, 2.372 centimeter inverse, and D is 3.62 centimeter inverse. So it is your question number 10. So 1.166 centimeter inverse. So the specific conductivity of N by 10 KCl solution at 20 degrees Celsius is 0.0212 ohm inverse centimeter inverse, and the resistance of the cell containing this solution at 20 degrees Celsius is 55 ohm. So the cell constant is 1.166 centimeter inverse. So here option B is the right answer for the question number 10. Next is the question number 11, and the question number 11 is Faraday's laws of electrolysis is related to option A is atomic number of cations, B speed of cations, D speed of anions, and D is equivalent weight of the electrolyte. So Faraday's laws of electrolysis is related to either atomic number of the cations, speed of the cations, speed of anions, and equivalent weight of the electrolytes. And it is the question number 11. So Faraday's laws of electrolysis is related to equivalent weight of electrolyte. Equivalent weight of electrolyte. So here option D is the right answer for the question number 11. That is the Faraday's laws of electrolysis is related to equivalent weight of the electrolyte, not atomic number of the cations, not speed of cations, and even not speed of anions, but it is directly related with the equivalent weight of the electrolyte. So here option D is the right answer. Next is your question number 12, And your question number 12 is the molar conductivity is maximum for the solution of concentration. Options are 0.004 mole, 0.002 mole, 0.005 mole, and 0.001 mole. So the molar conductivity is maximum for the solution of concentration. So the molar conductivity is maximum for the solution of concentration is 0.001 mole. Option D. So here option D is the right answer for the question number 12. That is the molar conductivity is maximum for the solution of concentration is 0.001 mole. So here option D is the right answer. Next is your question number 13, and your question number 13 is units of the properties measured are given below. Which of the properties has not been matched correctly? Options are molar conductance, meter inverse, specific conductance of second meter square, and D is equivalent conductance, second meter square, second meter square inverse. So units of the properties measured are given below. So which of these properties has not been matched correctly? इनमें से कौन सी properties हैं that are not matched correctly? It is the question number 13. So out of these properties, the properties which are not matched correctly is the specific conductance of second meter square. So this is the properties which are not matched correctly. So here option C is the right answer for the question number 13. Next is the question number 14, and the question number 14 is how long would it take to deposit 50 gram of aluminium from an electrolytic cell containing Al2O3 using a current of 105 ampere. 105 ampere. Options are 1.54 hour, 1.42 hour, 1.32 hour, and 2.15 hour. So how long would it take to deposit 50 gram of aluminum from an electrolytic cell containing Al2O3 using a current of 105 ampere? It is the question number 14. That is 1.42 hour. So here option B is the right answer for the question number 14. Next is your question number 15, and your question number 15 is the charge required for reducing 1 mole of MnO4 to Mn2 negative is 1.93 into 10 raised to power 5 coulomb, 2.895 into 10 raised to power 5 coulomb, 4.28 into 10 raised to power 5 coulomb, and D is 4.825 into 10 raised to power 5 coulomb. So the charge required for reducing 1 mole of MnO4 to Mn2 is either 1.93 into 10 raised to power 5, 2.895 into 10 raised to power 5, 4.28 into 10 raised to power 5 coulomb, and 4.825 into 10 raised to power 5 coulomb. It is a question number 15. That is 4.825 into 10 raised to power 5 coulomb. 4.825 into 10 raised to power 5 coulomb. So here option D is the right answer for the question number 15. Next is your question number 16, and your question number 16 is how much electricity is in terms of Faraday is required to produce 100 grams of calcium from the molten calcium chloride. How much electricity in terms of Faraday is required to produce 100 grams of calcium from molten calcium chloride? Options are 1 Faraday, B 2 Faraday, C 3 Faraday, and D is 5 Faraday. So the electricity that is in terms of Faraday is required to produce 100 grams of calcium from molten calcium chloride is 5 Faraday. Is 5 Faraday. So here option D is the right answer. Next is your question number 17, and your question number 17 is if a current of 1.5 ampere flows through a metallic wire of 3 hours, then how many electrons would flow through the wire? Options are 2.25 into 10 raised to power 22 electrons, 1.13 into 10 raised to power 23 electrons, 1.01 into 10 raised to power 23 electrons, and 4.5 into 10 raised to power 23 electrons. So if a current of 1.5 ampere flows through a metallic wire, that is for 3 hours, then how many electrons would go through the wire? It is the question number 17. It is your question number 17. That is 1.01 into 10 raised to power 23 electrons. 1.01 into 10 raised to power 23 electrons. So here option C is the right answer for the question number 17. Next is your question number 18, and your question number 18 is how many coulombs of electricity is required to reduce 1 mole of Cr2O7 in acidic medium? How many coulombs of electricity is required to reduce 1 mole of Cr2O7 in acidic medium? Options are 4 into 96,500 coulomb, 6 into 96,500 coulomb, C 2 into 96,500 coulomb, and D is 1 into 96,500 coulomb. So how many coulombs of electricity is required to reduce 1 mole of Cr2O7 to negative in acidic medium? And it is your question number 18. That is 6 into 96,500 coulomb. 6 into 96,500 coulomb of electricity is required to reduce 1 mole of Cr2O7 to negative in acidic medium. So here option B is the right answer. Next is the question number 19, and your question number 19 is a current of 1.40 ampere is passed through 500 ml of 0.180 molar solution of zinc sulfate for 200 seconds. What will be the molarity of Z2 positive ions after deposition of zinc? Options are 0.154, 0.177, 2 mole, and 0.180 mole. And it is your question number 19. A current of 1.40 ampere is passed through 500 milliliter of 0.180 solution of zinc sulfate for 200 seconds. So what will be the molarity of zinc 2 positive ions after deposition of zinc? So it is your question number 19. That is 0.177 mole. 0.177 mole. So here option B is the right answer for the question number 19. Now shift to the question number 20, and your question number 20 is how much time is required to deposit 1 into 10 raised to power 3 centimeter thick layer of silver on a surface of area 100 centimeters square by passing a current of 5 ampere through AgNO3 solution. Options are 125 seconds, B 105 seconds, not 105 but 115 seconds. First is 125 seconds, second one is 115 seconds, 18.7 seconds, and the last one is 27.25 seconds. So how much time is required to deposit 1 into 10 raised to power 3 centimeter thick layer of silver on a surface of area 100 centimeters square by passing a current of 5 ampere through AgNO3 solution? And options are 125 seconds, 115 seconds, 18.7 seconds, and the last one is 27.25 seconds. It is a question number 20. So that is 18.7 seconds. So this time is required to, that is 18.75 time is required to deposit 1 into 10 raised to power 3 centimeter thick layer of silver on a surface of area 100 centimeter square by passing a current of 5 ampere through AgNO3 solution. So here option C is the right answer for the question number 20. Next is the question number 21, and the question number 21 is the charge required for the reduction of 1 mole of MnO4 to MnO2 is 1 Faraday, 3 Faraday, 5 Faraday, and 6 Faraday. The charge required for the reduction of 1 mole of MnO4 to MnO2 is 1 Faraday, 3 Faraday, 5 Faraday, and 6 Faraday. So the charge required for the reduction of 1 mole of MnO4 to MnO2 is 3 Faraday. 3 Faraday. So here option B is the right answer. Not 1 Faraday, not 5 Faraday, not 6 Faraday. But the charge required for the reduction of 1 mole of MnO4 to MnO2 is 3 Faraday. Next is the question number 22. If limiting molar conductivity of Ca2 positive and Cl negative are 119.0 and 76.3 second centimeter square mole inverse, then the value of limiting molar conductivity of Cl2 will be. Options are 195.3 second centimeter square mole inverse, 217.6 centimeter square mole inverse, 43.3 second centimeter square mole inverse, and the last one is 314.3 second meter square mole inverse. So it is the question number 22. So if limiting molar conductivity of Ca2 positive and Cl negative are 119.0 and 76.3 second centimeter square mole inverse, limiting molar conductivity of CaCl2 will be 271.6 second centimeter square mole inverse. So here option B is the right answer for the question number 22. That is 271.6 second centimeter square mole inverse. So this is the right answer for the question number 22. Next is the question number 23. NH4NC greater than 3 is used in salt bridge because it forms a jelly-like material with agar-agar. It is a weak electrolyte. It is a good conductor of electricity, and the transport number of NH4 positive and NO3 negative ions are almost equal. So it is the question number 23. Are almost equal. So NH4NC greater than 3 is used in salt bridge because the transport number of NH4 positive and NO3 negative ions are almost equal. That is, the transport number of NH4 positive and NO3 negative are almost equal. So here NH4NC greater than 3 is used in case of the salt bridge because the transport number of NH4 positive and NO3 negative ions are almost equal. So here option D is the right answer. Next is your question number 24. The reaction 3ClO aqueous give rise to ClO3 aqueous plus 2Cl negative aqueous is an example of option A is oxidation reaction, reduction reaction, Disproportionation reaction, and the last one is decomposition reaction. And it is the question number 24. The reaction 3ClO negative aqueous give rise to ClO3 aqueous plus 2Cl negative is an example of Disproportionation reactions. So here option C is the right answer. Disproportionation reaction. Not oxidation reaction, not reduction reaction, and even not decomposition reaction. And it is our last question for our today's live video lecture. That is the EMF of the cell. That is the electromotive force of the cell is Ni2 positive 1.0 mole, Au3 positive 1.0 mole, Au E0 is equal to minus 0.25 volt for Ni2 positive. Ni E0 is equal to 1.5 volt for Au3 positive. Au is 1.25 volt minus 1.25 volt, 1.75 volt, and the last one is 2.0 volt. Options are 1.25 volt minus 1.25 volt, 1.75 volt, and the last one is 2.0 volt. So the option is 1.75 volt is the right answer for the question number 25. So here option C is the right answer. That is 1.75 volt. So here beta, this is all about our today's live video lecture. And in our today's live video lecture, we will discuss the chapter number 3 from the chemistry part, and the name of the chapter is Electrochemistry. And in this chapter, we will discuss important 25 MCQ questions or objective questions regarding this chapter. तो कल बेटे हम आपके साथ दोबारा एक नए चैप्टर के साथ और नए ऑब्जेक्टिव क्वेश्चंस के साथ दोबारा मिलेंगे. तब तक सभी स्टूडेंट्स जो इन क्वेश्चंस को गो थ्रू करें और रिवाइज करें. सो वंस अगेन गुड नाइट टू ऑल द स्टूडेंट्स हु ज्वाइन विद अस आवर लाइव APS classes.